Now let's take the two charge particles, positive and negative charge particles. See, what is the direction of B bar? B bar here is into the plane. Okay, there's a uniform magnetic field. We'll indicate bold letter. There's a B. Now, what do you mean by this? Into the directed into the plane. Let me choose two charge particle. One positive charge particle. With a velocity, another negative charge particle. How do they will move? Again, open up, close all the fingers, put B bar in the direction of field. Let's discuss the positive charge particle. I think just now we have discussed the similar thing is what we are going to apply it. I'll bring the circle. This is for this positive charge particle. It's going to describe a circular path like this. Now, what about the negative charge particle? The negative charge particle is going to describe a path like this. I'll indicate the velocity vectors. Very, very small essentials. One has to understand first these things. Rest of numerical very easy. Kinematics, just a very good revision of kinematics. I don't call anything. This is some very good topic. Just revision of kinematics here. Now, there's a charge particle positive. There's a negative charge particle. I'm already showing it hereby. Sir, why do they will deviate? Okay, let's get into the force, the calculation of force. The force acting on here it will be like this. The force acting on this particle will be like this in this direction. So now this will be the center. This will be the center. Okay, this you call F2. This force as F1. B bar velocity. For negative charge particle, the same force should act downward. Then it's going to describe a circular path. What about the radius of both the path? Will be same. The radius of both the path will be same. So what is the radius R? Here also radius R. So what is R is equal to mv by qb. What about the time period? Time period is going to be same. So it's all about the different types of numericals we have to pick up, and we have to study the motion of this charge particle. Nothing big. So positive charge particle. Now positive charge particle, if you give velocity towards left, the same thing if the for positive charge particle, if you give velocity towards left, some changes will come. Okay, now this is I'll draw a fresh one. I think it's troubling me a lot. Okay, here only I can bring it here. Oh. all get messed up. Okay, let me draw a fresh one. Huh? All this is not possible. Let me go for fresh one. Here I just wanted to tell you that here if you give velocity, how the particle will move. It's going to move in a curved path like this. And this negative charge particle is going to describe above. This is something very important. So you put that one, B bar velocity. If the velocity is like this, no, the positive charge particle is going to move in the lower circular path. This is going to move in upper circular path. Plenty of numericals will come like this. The very, very, very good numericals will be coming. But the idea, the method is same. The method is going to be same, that one. Okay, let me first draw that circles. Huh? That's troubling me a lot. Now, we will describe the negative positive charge particle will describe this path, and the negative charge particle will describe this path. The negative charge particle, which is here. Let me give a little bit gap to indicate all the things. Okay, this is the negative charge particle. And this is the positive charge particle. So here it is given velocity v. This is given velocity v. Sorry, this is. And the negative charge particle is given velocity v like this. So it's analyzed now. Everywhere the force is into the plane. No, analyze here. B bar velocity. The negative charge particle will move in a circular path like this. The force will be acting on it in this direction. Here the force on this will be in this direction, and the radius will be same. Hope everyone is able to imagine. So these are the wide varieties of numericals you do come across. Everyone, these are the only basics. I think we should say, sir, thank you very much. Okay, we'll manage problems. Yes, this is what you look at any numerical. There is only one formula, F equal to Q V bar cross V bar, the Lorentz formula. Based on that, all the things will revolve. We'll take the next situation. Now, what is the field? The field is such that the dimensions of field is such that they are greater than R. Shall we take a situation where the dimensions of the field is less than the radius of circular path? Then what will happen to the charge particle? Means inside the magnetic field, we have projected a charge particle. Then we are seeing this condition. So what happens if a charge particle enters a magnetic field? Any conditions that we are going to analyze here. So here, so can we give any name for topic? Charge particle projected inside a magnetic field, projected in a magnetic field region. And what is the condition? The dimensions of field is very much greater than the radius of circular path. Now let's say that charge particle enters a magnetic field, then we'll see what conditions will come. If a charge particle